Okay, and we are live. So welcome to Code for Kids, our third webinar. And we welcome Chris Betcher today he's tuning in from Sydney, but recently back from the States. So I'm just going to do a screen share with you.
Hi, Kelly.
Hi, Chris. I was going to introduce you with a picture.
Oh, were you? Oh, okay.
Just so you know who you are. Let me just try this again.
Just while you're working that out, I'll just say to people, I'm looking forward to this tonight. We're going to be talking about one of my favourite things is Scratch. And
yes,
we're actually going to build something together. And hopefully all the people watching this will learn some stuff from watching a little Scratch program being built.
Yes. I'm actually going to skip showing you the picture because it's not actually working properly. I can't get this screen up. So we're actually going to jump straight in. And so Chris is actually from the EdTech team, and it's great that we can have him here to help us because Chris actually is a bit of an expert with Scratch. I like to think he is. And we are going to be looking at Scratch from a beginner's point of view and different things that you can do with the program. So let's get into it.
All right. So, sounds good.
Chris, did you want to add anything before we?
Oh no, let's just get straight into it. Yeah. So you are going to present the screencast window. That's the one.
Yep.
So hopefully everyone now watching this is the screencast of Scratch running on my Chromebook. Yes.
We've got how many computers going, Chris?
Personally, I have 3 and two mobile phones sitting next to me, so I already have more computers than they once said would exist in the whole world. So, yeah. So, where do you want to start with this, Kelly? So, do you want to make something in Scratch, huh?
Yeah, let's make a program or a game. I mean, to show people how to use this program.
All right. So, before we make a program, I want to do something with you. First of all, I'm going to figure out why I'm getting no. Well, I can't hear myself. Oh well, I'll work it out. Think of a number between 1 and 100, but don't tell me what it is.
Okay. Yep, I've got it.
Okay. 76, and you have to tell me whether your number is higher or lower than my guess.
Lower.
Lower. 22.
Higher.
45.
A little bit higher.
50.
Yes.
Okay, all right. So I got a couple of guesses. Before we get into coding this, I want us to write a program in Scratch that actually does it is that game called the guessing game, where the computer thinks of a number and the user of the computer has to guess what the number is, and the computer will say higher or lower until they get the number, just like what you and I just did. Okay, where you were being the computer.
That sounds like a great game.
Okay, so before we get into coding it, let's just dissect it for a second. Let's pull the problem apart. So what's actually happening here? Step me through it.
All right, so I can see that there are blocks, and that the blocks tell me.
Forget the blocks for a second. Forget the blocks. Let's just think about logic for a second.
Okay.
What's the logic of the game?
Logic.
Yep.
The logic of the game that you just described.
Yeah. So the computer thinks of a number.
Yeah.
And then the user guesses
so the logic of the game. Yeah. So that is the logic of the game. The user will guess the number.
Assuming the user doesn't actually guess the number first go, and the computer then says higher or lower. How's the computer making that choice about whether to say higher or lower?
Well, the computer has to have some sort of action to know whether it's higher or lower.
Okay. So if it's higher,
the computer has to have something.
Sorry, got a bit of lag. Go on.
The computer has to sort of recognise, I suppose, that the number is going to be, it needs to go higher or it needs to go lower.
Okay. And then what if it doesn't get it? What does it do next?
So then it tries again. So it repeats the process.
Right, okay. So we've got a couple of really important programming constructs in place here. One, first of all, is the computer has to think of a number. And we're going to use a thing called a random number generator. So we're going to get the computer to randomly come up with a number. Then we're going to store that number in memory. And we're going to use a programming construct called a variable. Okay, so we're going to store that number the computer thinks of as a variable. We can call it X, or we can call it whatever we like, but it's called a variable in computing terms. And then what we're going to do is get the computer to make a comparison using Boolean operators, so whether it's greater than or less than. So we're going to make a comparison between two things. And then we're going to make a decision based on the outcome of that comparison. If it's higher, we'll do one thing. If it's lower, we'll do another thing. And then we'll keep doing that by repeating that loop over and over again until eventually we guess the number. So what I'm trying to build here is something that actually uses some really important computing constructs, and that is generating numbers, storing numbers, repeating things, and making decisions. Sound fair?
Yeah, that sounds good.
So let's get started.
Variable, when we're using a variable, that means we can actually change that variable to anything, and it's going to recognize it because it's within the context.
Yeah, yeah. So let's build the cat. So you can see the cat there on the screen, yeah?
Yep.
All right. So first thing, how would you like to start this game? How about when we click on the cat, that signals to start the program. So what I would do then is to go to this thing that says events, and I've got a whole bunch of events here. And an event is something that happens in a program that causes a trigger of something to happen. So we've got a whole bunch of options. We could trigger it when the green flag is clicked or when we press a certain key. But let's do this when this sprite is clicked. Now this cat is actually called a sprite. I don't know why it's called a sprite. That's just the word for it.
I always thought that was just the name of the cat.
So a sprite is just, I tell the kids, a sprite is another word for character, but they don't use the word character because these things could be objects as well as, people and animals. So you could have an object that was a rock, for example, which you wouldn't really call a character, so they refer to it as a sprite. That's just a term that they use in animation. So this sprite, we're going to say when this sprite is clicked, something's going to happen. And the first thing, it's going to say something. It's going to say pick a number. Just like I said to you, think of a number between 1 and 100. So we need to get the computer to do that. Now, you can get the computer to say things by going to this category here. If I do this, does that zoom in for you?
No, really. It's put the...
Not really.
No,
not really. Okay, no worries. So you go to this category called looks. And in the looks category, in fact, let's just backspace a little bit. Have we got people watching this who have never seen Scratch, do you think?
I reckon. I think that's why they've registered. Yeah.
Let's just back up a second. So over on this side here, this area where the cat is standing, this white space over here, that is called the stage. And the stage is where all the action happens. And when you tell the computer to do stuff, it'll take place on the stage. Below that, this area down the bottom here, is where you have your sprites or your characters. So if I wanted two characters to interact with each other, I'd need to create more characters. I can actually do that by clicking on this little blue guy there. When I click that, it opens up what's called the sprite library, and I could have another character. Say I want an apple, which is not really a character, and that's why they're called sprites. And you can see now I have two characters sitting down here, and I can make those things interact. Now I don't want the apple, so if you decide you put something in there you don't want, if you just right-click on it, you can delete it just as simply as you put it in there. So really easy to add or remove sprites. Over in this middle section here, this is called the code block area, and what these little, in this case purple, but if you see if I change the categories at the top here, I get a motion, I get a whole bunch of blue ones, I get a sound, I get a whole bunch of pinky purple ones, and so on. Each one of these categories has these things called blocks, and I can grab these blocks and drag them out onto this area here where I assemble the code. And it's a little bit like putting Lego blocks together. This block here says move 10 steps. So for example, if I was to click those two things together by bringing them close to each other, and let's make it a bigger number than 10, let's make it say 50. So I'll just typed in and changed the 10 to a 50. Then when I click on this sprite, you see it moves forward by a little bit, and that little bit is in fact what Scratch calls 50 steps. Does that make sense?
Mm.
Okay, all good. So all I have to do to get my cat to do something is to assemble the instructions in the correct order over here on this side, and when I click the sprite or tap the key or whatever I've told it to be the trigger, those things will happen in the order that I've got them. So pretty simple. If you decide you don't want a code block, you tear it away just like that, and if you don't want it at all, you just drag it off and drop it back into the code block area and it goes away. All right, so let's get into this little guessing game thing here. Now, I should point out the guessing game thing we're about to do is easy, but not simple. And that is, it's an easy idea. That's like a lot of things in computing. It's easy to think about. When I played the game with you, it was really easy. You got it straight away. When I asked you to describe the steps involved, that's a little harder. And what you'll find as you're teaching this stuff is kids have no trouble using the actual program. It's easy. What they have a lot of trouble with is breaking problems down into logical steps. And that's where we teachers really need to step in and help kids think clearly, think logically, ask some questions. What would happen next? What needs to happen before that? What would happen after that? And just by questioning kids constantly about, you know, what needs to happen next, you get them to really break down problems into steps. And I love it when kids say to me with Scratch, you know, can I do such and such? You know, can I make the cat do blah, blah, blah? Or can I? And the answer is always yes. All you need to do is figure out to do that. If you can figure out how to describe something in Scratch, you can make it do anything you like, which is really kind of encouraging and exciting. So when with Sprite is clicked, we're going to ask the cat to say something, and you'll find the saying things in this looks category here. And here's one that says say hello for 2 seconds. Well, let's click that up there. But we don't want the cat to say hello. What should it say, do you think?
Are you referring to the Guess My Number game?
Yeah.
Or just in general? Okay,
no, in this
so we want
particular
to say... Okay, so we probably want the cat to say, think of a number.
Okay. Think of a number. And that could be enough, but we should probably guide people a little more and tell them what the bounds are. So think of a number between let's say 1 and 100. Yeah?
Yep.
Think of a number between 1 and 100. Now, the computer's now got to pick a number. And we've got a really cool thing over here in this little green section called operators called pick random 1 to 10. We don't want 1 to 10, we want what? 1 to?
1 to 100.
100. So we changed the 10 to 100. So we're going to pick a random number 1 to 100. The trouble is after we pick this number, the computer's got to remember it. It's got to put it somewhere. And so that's where this other really interesting thing comes in called a variable. So in this orange section called data, there's a button that says make a variable. So I'm just going to make a variable, and let's call it num. We could call it number or num or x, or we call it anything you like. But let's just go with num, nice and simple, right? Num for number. So we'll put that in there. Now, so we've now got a block called num, and you actually see up in the corner of the screen here, so it says num0. So I'm going to drag this little thing out here that says set num to, and then I'm going to grab this green block and drag it inside there. And you see when I get close to it, it sort of glows white. When I let it go when it's glowing white, it actually pops into that box. Right, so we've got a non-working program so far, but let's test it. When the sprite's clicked, the cat's going to say, think of a number between 1 and 100 for 2 seconds, and then internally the computer's going to pick a number and assign it to this variable called num. And we can actually see it's working, because up in the corner here, this little box in the corner, we're going to see that change to a number if this is working. So let's try it. Click on the cat. Great. Cat says, think of a number between 1 and 100. And if you look up in the corner here, it says num71. So the random number in this case is 71. Now, when we're playing the game, we won't show this to people, obviously, or it's not much of a game, right? So we would just go in there and untick that box. But when we're building programs, I really like to leave that box ticked, because I like to be able to see what's going on in the background, and we'll turn it off later once it's ready to run. All right, so let's just test it again one more time. Click the cat, think of a number between 1 and 100, and it changes to 95. Let's test it one more time. Think of a number between 1 and 100. And it's gone to 76, and so on. Every time I do that, it's going to be a different number. All good.
Yep.
Okay. Now we need to do a couple of things here. This is a process that we're going to keep guessing until we get it. So in the control section, there's a thing that says repeat until. I'm going to drag that out. Now this thing is called a loop or a repeat. I call them loops. But it's going to just keep going round this loop until a condition is true. So here we're going to say repeat until. What's the thing that is we'll come back to that. We now need to ask.
Okay, so
yeah, please interrupt.
Got a question.
Yeah.
Just got a question come through. Wouldn't the cat be thinking of the number, not the user?
That the cat is thinking of the number, yeah.
Yeah, so yes, the cat would be thinking of the number, not the user.
This random generation of a number is done by the computer, which in this case is the cat, not the human.
Yeah.
I'm just leaving that box ticked in the corner there because while we're building the program, I want to see what this number is so I can troubleshoot the program in case if I don't have that ticked and I can't see the number, then I don't know what's going on behind the scenes. So, but that's definitely going to be turned off as soon as we're ready to actually play this game. Okay.
Thanks for that question.
That answers that question. Yep. Yeah, thanks for the question. Now, we now want the cat or the computer to ask us to guess a number. So I'm going to grab this blue block here and drag it out there and pop it in there, just like that. And I'm going to ask here, what's your guess? What's your guess? Just like that. And wait. Now, the way this blue block works is when you ask a question, whatever you type in next goes into this special variable called answer. And if I can just show you how that works, let's tap the cat again. So it thinks of a number between 1 and 100. It's guessed a number. I can see up in the corner it's 49. But you see down the bottom of the screen under the cat, it's waiting for me to type something in now. So that's what the ask block does. It lets you put a question in there and the whole program just stops until you type something in. So if I was to type in 49, right, nothing happens yet because I haven't told it to do anything with that yet. We haven't got to that part yet. All right, so we've asked what's your guess and we waited. So far, so good. Now, let's create another variable. And I know for anyone who's not done this before, this is going to seem a little confusing, but trust me, the logic will all become clear. I'm going to make another variable. I'm going to call it guess. So I now have two variables, right? And I want to set the guess to whatever they typed in as their answer. And I'll find that where I asked the question here about asking, immediately underneath it, it says answer. See that? So I'm going to take that thing called answer and drop that into that little hole like that. So I've got two variables. One's called number, one's called guess. And really what I want to say is the guess equal to the number? And if it is, then the game will be won. People won't get it first go because that's 1 in 100 chance, right? All right, so set guess to answer. And you can see what's happening up here in the corner here. Let's just run this again and just see what's happening. Think of a number between 1 and 100. What's my guess? I can see the actual number the computer's thought of there is 84. I can see that the answer I type in, let's say it's 56, right? And you can see that guess becomes 56 and answer becomes 56 because when I typed in 56, I've got code there that says set guess to answer. Does that make sense?
Yes.
Excellent. Great.
Yeah. I can see what's happening there.
Now comes the interesting part of this is we're going to start comparing. We're going to start saying, because you and I both know that in the real world you're probably not going to guess this first go. So we're going to have to do a couple of little logical things here. So the first thing we're going to do is say if something happens, if we want to compare two things. Well, that's called an operation. So you'll find it here under the green operators. We're going to say if, here's a greater than and less than. Here's the less than one. We're going to say if num, which is the number the computer's thinking of, is less than guess, which is the number that the person's typed in, then what are we going to say? If the number is less than the guess.
If the number is less than the guess.
Yeah. So let's say the computer's thinking of the number 50, and I type in the word 60. What's the computer got to say?
It's got to say higher or lower.
Yeah, so which one?
Say lower.
So lower. It's going to say lower, right. So let's go back to our little looks thing here and grab this say something. And in this case, what it's got to say is lower. Okay. So far, so good.
So it's really relying on the less than and more than sign, really.
Yeah, it's doing a comparison there with that. So we'll get this written, and then we'll play it a couple of times, and it'll all become really clear how this is working. So let's just do the next. So we've accounted here for if the number is lower. Oops, sorry, do that. Let's figure out what happens if it's higher. So let's go back into control one more time. Grab another one of these if loops, pop it in there, and this time we're going to look for the one that says greater than. Drop that in there, and this time we're going to say if the number the computer's thinking of is greater than the guess, then what have we got to say now?
And higher.
Yeah, right. So say higher for 2 seconds. All right. Let's see how this goes. Now, let's see what happens here. I'm thinking of a number between 1 and 100. Now, I know, because I can see the numbers up in the top corner, that the number the computer's thinking of is 34. Normally, I wouldn't know that. That'd be secret information, right? So 34. So if I type in here 50 and press enter, the computer should say lower, right? Perfect.
Yeah.
Okay. If I type in a number that's lower than 34, like say 20, it should say higher, and it does. And if I guess the number, which is 34, and I press enter, what's going to happen?
It's not going to say anything because we haven't put anything in for it to say for that.
Right, it's not going to say anything because we haven't actually added that code yet. So where would we add that, do you think? So it needs to say something. So it needs to say something. I'll just put it out here. Let's say correct. Let's just make it say correct. You win. Okay, and where would that go, do you think?
Would it just go at the bottom of the whole?
Yeah, exactly right. Exactly right. Now I want you to, I want you and our watchers, our listeners here, to look at how the logic of this works. So we've got a thing here that says repeat until, and we haven't actually finished that off yet. So tell me, what do you think's going to go in there?
So repeat until.
So I'll give you a clue. Down here we've accounted for the case of if num is less than guess, and we've accounted for the case if num is greater than guess. What's the remaining use case that we need to consider here?
The correct guess.
Right, in which case that's going to be if num
equal to.
Is equal to. Right, so if num, drag that out there, is equal to guess. Now I know this program is a little more complex than, typically when people start writing Scratch programs, they literally do like move the cat across the screen or something really simple like that. And that's fine. That's a great place to start.
Yep.
That's a great place to start. I guess what I'm trying to do with this example here is show you a fairly simple program. I mean, we've got like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's about 13 lines of code there. It's not a big program, but it includes so many ideas of programming that's a really good example of getting someone to think about, how you would get flow happening between here. So let's just think it through together. When we click the sprite, it says something and displays those words. Then internally, it sets this random number that we don't see. So let's actually turn these off now so we don't see any of those. That makes it more interesting, doesn't it? And then we repeat this process until the number the computer's thinking of equals the guess we've made. And when that happens, falls through this loop all the way to the bottom there and says correct, you win. But until this is true, it's going to keep going around and around in circles around there and saying, all right, well, ask what's your guess, and then wait for an answer, and then it puts the guess to the answer, and then it compares the number in the computer's memory to the guess that was just made, and says, well, if it's less than, we'll say lower, if it's more than, we'll say greater, and if it's neither, we'll go around the loop again, and we'll keep going around the loop again until the condition number equals guess becomes true, in which case we fall through the loop and we say correct, you win. Make sense?
Yeah.
Let's actually do it. Let's here we go. So
I like how it's using so many.
Oh no! Oh no! Kelly just dropped off. I don't know what that does to the broadcast. I'm hoping she'll come back in just a minute, so I'll just keep talking. So so you guys watching, hopefully you can still see this. Let's play it. Let's see what happens. So I click the sprite. Think of a number between 1 and 100. The computer is now thinking of a number in the background. I have no idea what it is because I turned that feature off. What's my guess? Let's say 67. Lower. Let's say 34. Higher. Let's say 56. Lower. Let's say 40. Oops, 40. Lower than 40. 35. Higher than 35. 37. Higher. So it's got to be 38 or 39, right? 38. Higher. It must be 39. Oh. What happened there? Correct. There you go. Correct. You win. So the number was 39. So that's how that works. And I won't call this a simple program because it actually uses a lot of programming ideas, but I wanted to show them to you guys tonight because I think it's important that she's back. There she's back.
Sorry, I don't know what happened. It just dropped out and said that I wasn't authentic to use.
Oh, that's all right. Let's just hope the recording kept going. Does it still say recording? It still says live.
Yeah, yeah. It still says, probably because you're still on. Okay.
So I was just talking people through it and saying that this is not a simple program. This is not in terms of, there's a fair. You probably need to have used Scratch a little bit before you get to the point where you can write this program. But I think it's really important that you see something a little more complex than just simply move an object or make the cat walk in a square or something like that, which is a great place to start, but not a great place to finish.
Yeah.
So I played it while you were away. I'll just show you one more time. So click the cat. Says think of a number between 1 and 100. What's my guess? Here, you go. What's your guess?
My guess is 32.
32. Oh, lucky guess. Nice work. Let's do that one more time.
And that's the same, I like to say.
That's pretty good. Pretty good. What's your guess this time? See if you can do it twice.
76.
76. Lower.
50.
50. Lower.
25.
25. Higher.
30.
Higher. So we know
2.
30.
Could it be 32 again?
32 again. Higher.
40.
Higher. Between 40 and
45.
50. 45.
45. Yeah.
Higher.
49.
49. Lower.
48.
Lower.
These guys always this is paying me back for getting it first time. 47.
47. Lower. It can only be one more option.
46.
Correct. You win. Right.
That reminds me of the kids in the class going, yeah, no, yeah. That's really good.
So there, that's how you write a really simple game in Scratch. I mean, you can write anything in Scratch, all sorts of things, but I just thought that was an interesting example. If you don't want the cat, I just want to show you one last thing if you don't want the cat, and that is over here in this center section here called Scripts, where all these blocks are kept, you notice there's 3 tabs across the top. One's called Costumes, one's called Sounds. and you can actually add what's called costumes. So this cat at the moment has 2 costumes, and you can see if I switch between the costume, it appears to animate the cat. The cat appears to sort of do that walking motion. What I could actually do is add another costume in here, and let's go with something like let's do this little thoughtful-looking girl here called Alex B, and we'll put her in there like that. And you can see that now, as soon as it finishes saving that change, now I've got just a different character. It's the same sprite wearing a different costume, and if I wanted, I could actually come over here and throw the other 2 costumes away, so that was the only costume left. So it's pretty easy to swap a character the way they look if you want to do that. And the other thing is that the stage area that this girl, this sprite is standing on, is represented down here with this white square in the corner called the stage. And when you click on stage, you can also do the same thing here by choosing a similar idea. We choose a new backdrop. And so I could have this girl standing in, I don't know, this blue sky here. So we'll do that. And now she's got a different background. Let's maybe move it down a little bit so it looks like she's standing on the ground. And there you go. So if I go back to the scripts, let's go full screen. Here's our finished program. Let's click on the girl. Tell me, what's the strategy for doing this in the shortest amount of time? How could you solve the guessing game in the least number of guesses?
So the strategy would go halves.
Right.
Halves every time.
Right, yep, exactly right. So if we go 50, lower, 25, 25, higher, let's try 37, lower, what should we go for?
So
about 28,
30.
30?
Yeah.
Higher, 35, lower, 32.
32.
So it must be 34, right? Right.
Yeah.
So
yeah,
it's really interesting when you watch kids do this after they built this game, and sometimes they need a little bit of help to build it. But after they build it, it's interesting to watch them use it because you'll get the kids who, you think, okay, think of a strategy to get this done in the least number of goes. And some kids will go, 1, no, 2, no, 3, no, 4. Like they'll do a linear search for it. And then you start to talk about, well, what's a better way to do it? And you come up with what you just suggested, where you halve it and then halve it and then halve it. Yeah. And that's the fastest way to get to the result.
Yeah.
And that computational idea, because we're talking about digital curriculum here, and that's a computational idea about how do you guess something in the quickest possible way. Well, that's the best way to do it, is half, 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 and not work through in a linear search. So there's all sorts of really interesting ideas embedded in that little simple program.
Yeah, and also, Chris, the breaking down into the smallest problem, like you said that before, about how the game was to guess the number, but you had to break that down into smaller parts to be able to create a game, and that's a part of decomposing, which is part of also the critical thinking is coming out in the digital curriculum as well. So you could very easily take this now, if you wanted to, and create some sort of branching, or like a tree branched with like a tree with branches on it, to actually help to organize the information as well, as another way of looking at it, to visualize it in a different way.
Yeah, look, there's a whole bunch of things you could do from here, and you and I both know there's a whole bunch of teachers that are kind of freaking out a little bit about the whole notion of the digital technologies curriculum, because it's talking to them in language that they maybe haven't used much before, and you start to talk about computational thinking and scripting and programming and coding and all these sorts of words that sound a bit foreign. But I mean, I don't like to think about it in those terms. I look at that and I go, forget the fact that I've just coded into a game. Before we even get to that stage, it involves clear thinking. It involves taking a problem, any problem, and saying, how does that actually work? And I don't think it needs to be, I mean, people forget the computer for a second. It's got nothing to do with the computer until you get to the stage where you maybe want to replicate this idea in code, which is what we've just done. But if you can't break down the problem into clear steps, then forget the coding. You're lost before you start there, right? It's about clear thinking. It's about logic. It's about being able to analyze and dissect a problem into steps. And that has almost nothing to do with using a computer. Using the computer is simply just a way of expressing this idea once you've figured out how to do it in a very human way. And that is with clear thought.
I think that's a misconception, though, Chris, about how teachers feel that the digital technology has to be about the computer, and it's actually about the thinking processes that are behind what we're doing.
100%. All this stuff with digital technologies is all about getting kids to think clearly and providing them with a framework and a way of solving problems and a way of thinking about problems by either start looking at a problem in the context of how do I break this down into steps? How do I decompose the problem into smaller steps? Or how do I take this problem and look at it as part of a much larger scale view of something? And this program actually this problem actually becomes a step in a much larger process.
Yeah.
And you've got to be able to zoom in and out on a problem like that in order to see it clearly, in order to really think about it.
Yeah.
And
you don't have to.
That's applicable in so many areas of life.
You don't have to necessarily, like as you said, so many areas in life. You don't have to necessarily use a mathematical problem to do those. If you could use a Google My Map, and you could have a problem that needs to be solved about a location and infrastructures, and you might have to analyze that and decide on what's the best what's the best housing to have, where's the best to put the new housing estates, because what's around there, and it's break down that problem into smaller problems as well. So it's actually across across the board. This is one way of showing it, but there are many ways of integrating it into everything that teachers are doing.
Yeah, no, totally agree.
Well, we might leave it there, and thank you, Chris, for sharing this expertise with us tonight. I've learned a lot tonight. I did not know how to use the operations. So that was my new learning from tonight. I haven't used it before because, as you said, I'm one of the people that moves the cat across the screen because I haven't actually delved into the program enough myself, even though my students have. So it was great to actually see that in action and see a way of using it, and I can think of lots of ways to use that now. So I hope this has been helpful for other people as well. So thanks.
Can I just add one thing, and that is this idea of differentiated learning as well? I mean, if you start with something like that and then say to kids, where would you go from here? And it's like, well, what about building in a counter to see how many goes it took you to get the correct answer, and actually displaying a counter on the screen? And so then you can have competitions about who can guess it in the least number of goes. Or what about designing it so that it gives you like a best of 3? Or what about if you design it so that when you finish this one, then it goes to the next level and it becomes harder somehow? I mean, it's just that's the beauty of something like Scratch, is that it's so open-ended that really, if you can, I mean, it sounds like a cliche, but if you can dream it, you can build it. Like if you can just think of what you'd like it to do, and then think clearly enough to be able to describe those steps, you can make it do anything you like.
Yeah.
That's really empowering.
Just had a comment from Kevin here saying, thanks, Chris. I haven't played with variables too. I learned a lot. Sorry. So thank you, Kevin, for that. It's really good to hear it as well. The possibilities, and as you said, Chris, if you dream it, do it.
Good.
Just another, looking for advanced Scratch resources. Do you have any suggestions?
There's 2 books that I have on my iPad, actually, 2 Scratch books, and I forget who wrote them. If you just talk amongst yourselves for a second, let me grab my iPad and I'll tell you the name.
Yeah. Always great to have lots of different resources, and we can pop all those resources into the Google Plus community and also onto the website as well, so that people have a lot of information to walk away with of how they might use Scratch in their classroom. Really, as you can see, you can use it beginning from the very, very ends of it, so from the surface, and you can delve a bit deeper. So did you have those names, Chris?
Yep. Just finding it now. There's 2 books written by the same person.
Also, there's really good if you follow Scratch on Twitter and in their on their social media. They also release great things as well. And when they do have any resources, they generally will on there.
Yeah, so the book is called Basic Scratch, An Introduction to the Scratch Programming Language. And then the guy's written a second book called Beyond Basic Scratch. And I'll tell you the guy's name. Sorry, I'm just opening this now.
That's okay.
Basic Scratch by Eduardo A. Vlieg. Eduardo, Eduardo, and his last name is Vlieg, V-L-I-E-G. And it's actually pretty good.
So we might add those 2.
Yeah, it takes you through a whole bunch of exercises and programs and challenges and stuff. That's pretty good. The other thing you can do is on the Scratch website, there's ScratchEd. Is it scratched.edu,
yes,
I think?
Scratch Team, I think, or Scratch. And they've got lots of different teacher resources too, don't they?
They do, yeah. There's tons of stuff on ScratchEd. And I just sort of one more resource
Chris,
here that I might share with your listeners, if I can see if it's going to open. Yeah, so if you want to share the address, I've just brought it up on the screen there. So, is that the right one? I might have to modify this so anyone can do it. This was one I was doing with a Year 5 class. So this is a 15-question Scratch quiz, and there's a whole bunch of examples there, and it asks you to just look at the example and make a multiple choice option as to what you think the right answer is. And when you get to the end there, this is just a Google form, and I'm using Flubaroo to auto-mark it and auto-send you the results. So if you want to go over to bit.ly, bit.ly/scratchquiz, you might be able to check it for me, make sure it works okay.
Yeah, we might. Hang on.
But yeah, bit.ly/scratchquiz. If you head over there and just do the quiz, it will email you the answers straight away. So it might be a good little primer to introduce you to some concepts that you may or may not be aware of. But all my Year 5 kids could do it. So.
And Chris, is there a difference between Scratch Junior and Scratch? That link works, by the way.
It does work, excellent. So people can head over there and do that. It's got here that you have to use your school email address, but I'm not sure that's actually mandatory. I think you can use anything you like. Scratch and Scratch Junior, yeah, Scratch Junior is just for the iPad, whereas Scratch.
Okay.
So there is actually Scratch doesn't actually work on the iPad because it's Flash-based still. They're rewriting it at the moment for a new version of Scratch, but it's not out yet.
Yeah.
But yeah, it is definitely better on a browser, I believe. But Scratch Junior, same kind of ideas, but it's a much more simplified set of commands in Scratch Junior. It's aimed at younger kids.
So somebody's just said, can I share that link with students? Do you mind if that's shared with students?
Go for it.
And
we'll modify it so I can all that stuff about PLC on it as well. So
yeah, can't really allow you to modify it.
No, I'll do that. I'll modify it at the other end. Yeah.
Okay, and somebody else said Google Now's quiz grader. Do you know about that, Chris?
What was the question? What quiz grader?
Yeah. Google Now has Quiz Grader.
Oh, I think that person's saying that Google Forms now has quizzes built in.
Yeah, it does have quizzes built in. I'm thinking of that. That might be that person's referring to as well. Margaret's referring to as well.
Yeah. Yeah. No, this Scratch quiz you're looking at here was built long before that was available.
Can tell from the old forms.
Yeah. So it just uses Flubaroo and just auto grades and auto marks, and I've got it set to what do they call it? Auto trigger. So as soon as you hit the submit button,
Yeah.
it takes it out, marks it, sends you the results in an email, tells you what you got right and wrong, and you can keep doing it as many times as you like until you get the right answers, which is actually not a bad way to learn. When you're just trying to get that simple factual stuff across.
Trial and error.
Yeah.
Trial and error. It's great, isn't it?
It is.
Thank you for sharing your time with us, Chris.
That's okay.
It's been great to listen to you and learn from you, and I'm sure we're going to get you on again. After tonight.
I love talking about Scratch, as you can tell.
Yeah. It's great. So thank you. And this webinar will be put onto the Code for Kids website and up in the Google Plus community for others that viewed, or if you want to share it out to your school or friends, go for it. So other than that, we'll be seeing you later. Thank you.
Yep. No worries at all.
Thanks, Chris.